Okay, in this section we're going to be looking at how to calculate a mean from a frequency distribution. This can be really helpful when you're working with a really large set of data and you want to go through and you have a frequency distribution and you want to make a really quick estimate on what your mean is likely to be. So we're going to work through this with practice problem number 30 from your textbook. Here we're looking at finding the mean age of the actor when they won an Oscar for Best Actor Award using the frequency distribution that we've already computed for earlier in the semester when we were working with the other data. So we're going to take this and compare this to the computed mean that we get to the actual mean of 44.1 years old. We're going to do this by using the formula here. So here we see our formula for calculating the mean from the frequency distribution. And the first thing we need to look at this is start breaking down this formula. So when we're trying to think about how to get started, we need to first identify what do we know. This is a really important skill set for you to learn to be able to take outside of this classroom so that you can break down new formulas when you encounter them that you don't have previous experience with and learn how to be able to work with them. So many students, when first encountering a formula, freak out. It seems very scary. It's unusual. I don't know what any of this stuff means, and you panic. So being able to stay calm and productively and constructively start to break down a formula and figure out what the pieces of it mean and then how to get each piece and putting them back together again is a critical skill set. It's basically kind of like getting a puzzle. So you've got to figure out what you've got here, what are you trying to get to, and then you put the pieces together to get to that. So what we know from our statistical notation is the symbol here means sum of. So that's literally sum. That's what happens when you see this particular symbol. It looks kind of like a strangely shaped E. Now, if you look on page 86, you can get the meanings for the other symbols. So take a moment and take a look at those meanings, and then let's get back together again and work through the next step. Okay, so the other meanings are this cursive F always means frequency. Whenever you see it, that's what you're talking about. So again, this needs to go into your statistical notation sheet. All right, X in this particular example means class midpoints. All right, so again, remember X can be set to be lots of different things. So whenever you're solving a problem, one of the pieces of notation you're going to want to have is X equals, and what is X standing for in this particular problem that you're solving. Now, if we put these back in with our formula, we see that the lower level of it is simply the sum of F. So that part of the formula, although it looks a little bit strange, is basically just saying we're going to take all the frequencies that occur and sum them all up. And that is our sum of F. Now, the top part we're looking at here is a little bit more of a complicated formula. So we've got the sum of F times X, with F and X in the parentheses. Now, remember, this is where you have to pay attention to your order of operations. So we solve within parentheses first. We had several people that did a really good job of explaining this when they were doing the discussion board, getting to know each other and signing in for the class. So if you're not sure about that order of operations, I suggest you copy that down. Have that on a note card so you can refer to it. Again, this working outside of the correct order of operations is a place where people make a lot of mistakes. It's very difficult then to figure it out because it looks to you like you're following the formula, but you're actually doing the operations out of order. So when we're looking at this problem here, what we're going to do is we're going to multiply the frequency of each class by its midpoint. Then, after we've done that for each class, we're going to sum all of those values up. Thus, we work within the parentheses first, frequency times midpoint, and only after we've done that for all of our classes do we sum all of them up together. All right, so here we have this working our way through. We have our age of years when we won the Oscar. We have our frequencies from before. And you notice here in red, I've summed these up. So I have my sum of F, which equals 82. And then I've gone through and calculated my class midpoint for each one of them. Now, the class midpoint we get by taking the upper limit value, in this case 29. We're going to subtract the lower limit value, or in this case 20. And then we're going to divide that by 2. So that gives us 24.5 as my class midpoint value. Now, my F times X is going to simply be 1, in this case my frequency, times 24.5, since that's my class midpoint. And that gives me my Fx for the class of 20 to 29 as 24.5. So, take a few moments, pause here, go through and do these calculations for yourself. And then when you filled in your column, let's move on to the next page and check it together. All right, you should have gotten something like this. So here you can see I've worked across with my frequency distribution charts here. I've got my classes, my frequencies, my class midpoints, and now I have my column for F times X. Okay, now I sum all of those up. This gives me my sum of F times X that you can see here at the bottom. Okay, now notice in working through this problem here, I've used different color ink for each one of these sections. That is because, again, I find it easier to keep all of my information organized by colors. So I strongly suggest you do this yourself. Also, please be aware that when you're working through to solve this problem, if there are shortcuts that work, I will show you what they are. So there is not any way to answer this problem correctly without taking the time to draw out this chart and complete each of these columns one step at a time. There's simply not a quick way around it without sacrificing a great deal of accuracy. So you're going to need to go through these steps. All right, here. Now we've got our formula written here, and we're going to finish this up. So as you can see, we're going to plug our numbers into this. We're going to get a computed mean of 44.5. All right. So pause for this a moment. Make sure you've got this. You can go through and do all of these steps. So you've got the same number. And then we're going to go back and compare. Here we see that the computed mean from the frequency distribution is 44.5 years. Well, it's pretty comparable to the actual mean of 44.1 years. So as you can see, usually this is a pretty good example, a short route of getting to your mean if you're working from a frequency distribution, especially if you're having to look at something where you don't actually have access to the actual raw data, you can still get a rough estimate. All right, now that concludes our section on measures of center. Next up we're going to be looking at variation. So looking at this particular sample data, this is again coming from the Flint water studies that are ongoing. You can see when we're looking here that we've got the lead contamination for 3 different cities, right? So we're looking at Detroit at 2 weeks, Flint at 2 weeks, and then Flint and another location, I'm blanking on what the P stands for, at 2 weeks of stage. So we can see what was the lead content. However, notice that each of these particular histograms also includes a measure of variation. That is the thin black bar you're seeing, which is giving you the upper and lower range for the mean. So that is the variation around the mean. And as we can see, the variation is very different for Flint at 2 weeks than it is for Detroit. This will affect the accuracy of the mean in predicting scores. So that's what we're going to be looking at in the next section.